Hi everybody, welcome back to another Julia language tutorial series. I wasn't uploading for a while and I'm sorry. I hope I can go back into shape and continue my uploading and my content. So let's dig in. Recently I saw a paper about, well, it's about Earth map, and it's this paper by Gott, Goldberg and Van der Bay. I hope I'm correct in pronouncing all the names. And they are talking about improving the Winkel triple map. And the Winkel map is this map we know of. It's you've probably seen it. It's by National Geographic and all sorts of stuff. And this Winkel map is about minimizing three types of distortions. It's minimizing area, direction, and distance. And well, it's pretty old. It's from 1921, and it hasn't been improved by much since. But this new map they've created, you can see for yourself. They've minimized like six type of distortions, and I'm not gonna get into those types and how they did it because, well, I'm not a physicist and I really don't understand what they done. But from like looking shortly at the paper, what I saw, they ended the paper with those two images, was two discs of the Earth, and they encourage people to print them out and like glue them together to like a sheet of paper, and you can rotate them and like look at the Earth doing so. And it seems a bit weird to me because, well, I won't print them. I think we can do something a bit better using our computer, and I fired up Julia for this. And yes, we can start playing it with Julia. So this is what I've done, and let's bring everything we'll need for this session. So it's images, image, view, and image transformations. And I've saved those two images I've showed you in the paper. I will link the paper below, and I saved them to disk, and just we can upload them and start playing around with them and see what we can get. So, okay, just a second. Yes, so north image would be loading the image which I've saved at my pictures, and it's called Flat Earth North. And the second one will be south, and this time is south. And I'll scale them a bit, I'll downscale them a bit because they're pretty big. It will make our computations a bit faster, not that you need this in Julia. So like north small will be the resize of resize of north to scale and scale. There are a few versions of scaling. You can use a ratio, but because the original image is not a perfect square, it's almost a perfect square, so I used this version of two, like height by width, and it's better. So you can see that the size of south is 1514 by 1510, and the size of the small version is, as you can guess for yourself. So I thought about how to make a nice illustration, and there's this illustrations like Gott and Van der Bay, they work in Princeton, and you can see this illustration they have. It's in the Princeton site, so you can see about it is like a vinyl, and they can rotate it, and you see that like they're flipping it. And I don't know, this wasn't very intuitive to me, so I wanted to look at the two disks and like bring them together to a tangent point. So we can actually use a pretty simple function to do that. We can simply concatenate them, those two disks, like hcat is an horizontal cat. So let's take north small and south small, and let's show h. Yeah, it's always missing for the first time. Okay, yeah, and you can see that this looks nice. I mean, you can see Africa is the tangent point, and this looks nice. The problem begins if we're trying to use the vertical concatenation. So for this one, you can guess that. Okay, so let me just write it down and don't use the completion. So this version, you can think out, this is not the same place. I mean, this is North America and this is Australia, so they're not pointing the correct direction. We can fix this by rotating our image. Let's rotate the southern hemisphere for and we can use imrotate, and we'll rotate south. We can rotate him by 180 degrees, which is pi radians. So I'm using tab completion to make this as a pi, and we'll keep the axis. This is a nice syntax for Julia. Because the image is actually round, so we can use this type of preserving the axis. You can see what happened if you will not preserve the axis, but this is not very important for now. So let's show the vertical concatenation of north small and rotated, and let's see what will happen now. So yeah, now you can see that North America and South America are actually they're sticking together, and this is what we want to do. I'll use the horizontal view because I don't know, I prefer it better. So let's define some function that can find a function that will create our horizontal view no matter which direction we want to look at. So let's define the flat horizontal map, and we'll give it an azimuth parameter, which is the direction we want to look at, and we'll give it a will be one image. So to recall, we can use images are arrays of type T, array T, where T is actually some kind of colorant. So if you recall, this is like saying, well, it's any type of an image. The JIT will understand this. It will create a specific function for each colorant type. As I said, these images are RGBA. So if I don't want to specify that, this function can be called for any type of colorant type. So first off, we can actually translate our azimuth, which is given in degrees, to radians. So this is the formula, and now we can take a rotate will be rotate of a, and we'll rotate it by radians and preserve the axis. And the second one will be rotate, and we'll need to rotate it the other way around. So it's minus radians, and the axes are b axis. And we can bring back the horizontal cat of a rotate, b rotate. Yes. Okay, so we have our version, so let's check it a bit. Let's flat horizontal map, and let's say we want to rotate by 200 degrees. I hope it's a good number, and north small and south small. And we've got like this is Australia and New Zealand and Indonesia, and they are combining together. So yeah, this is nice. Next up, I wanted to make a video like pointing in all directions that we can think about. So first up, we need to actually collect all the data together to one sequence. So I'll create frames, which will be an array. So for azimuth in, let's create, I don't know, it's 2 rounds in jumps of 5 degrees. So we'll create 2 complete circles. And what we want to do is actually take our flat, or take our map, which will be the flat horizontal map of the azimuth we just created, north small and south small. And now we have this map. We need to convert it to RGB, so it will be able to encode it to video. So frame will be the convert of the image to RGB. And just to recall, the dot notation is applying the convert function on each element in the image. And lastly, we need to push. Push is add those all to append to the list of frames. And frame, yeah. Okay, so this is our function. So now we collected all. We collected 145 images into sequence, and now yes, I'll copy and paste some inputs. This is a video IO library, and now we can actually use this to encode our video. So this is the function, this is the properties we will use. Don't ask me about the exact properties, I'm not very familiar with this package, but this is how you do it. You can just check about it in the Julia Observer, and it didn't take long. So let's see what we've got. So and now we can actually fire up the image. So we called it flatmap.mp4, and yeah, we've got our rotating disks, and you can see that the tangent point is always viable. This is like the Pacific, North America, the Atlantic, as so on and so on. And actually, when I started working with it, I didn't know I wanted to make a video first. I actually wanted a more interactive way of doing stuff, and I used Pluto when I first started to play around with those types of images. And if you're familiar with JuliaCon and everything they show up, so Pluto is a very cool interactive notebook, and I want to show you a bit about it, and I think this will be my next video. So I hope you liked it. Hit the like, hit the subscribe, and thank you very much.